Morning. Let us continue the topic of electricity, in which today I am trying to explain about the second concept called potential difference. Now, in order to understand what is potential difference, let us consider this figure. Now, here we have an inclined plane. Okay, at point A, I kept a ball. Now, what will happen to this ball? This ball, due to the gravitational potential energy, will roll down, and the gravitational potential energy will be converted into kinetic energy. Now, why did the ball move from A to B? Because of the difference in the height. A is at higher height and B is at a lower height. In the same way, if we consider a hot body kept in contact with a cold body, we can say that the heat flows from hot body to a cold body. Now, why there is transfer of heat from hot body to cold body but not from cold body to hot body? Because the hot body is said to be at a higher temperature, whereas the cold body is said to be at lower temperature. So, heat flows from body at high temperature to a body at low temperature. Consider this example. Now, here I have two tanks, tank A containing full amount of water and tank B containing full amount of water. Now, if I open this, what will happen? Will there be any transfer of water from tank A to tank B? No, there is absolutely no transfer of water from A to B. Why there is no transfer of water? Because there is no difference in the level of water. Now let us consider the second example. Here the tank A is at higher level, whereas the water in the tank B is at lower level. What will happen if I open this connection between A and B? Water flows from A towards B. Now what is the reason? Why is the water flowing from A to B? As the level of water in A is more, A is said to be at higher level. As the level of water in B is less, B is said to be at lower level. So here the water flows from a level where the water is high to a level where the water is low. So when there is difference in levels, water is able to flow from tank A to tank B. Whereas in this case, as the levels are same, water is unable to flow. So, if you observe in all these three cases, to keep the ball here, some work is being done. So, this work gets stored in this ball in the form of gravitational potential energy. To heat the body also, some work is done. So, this work done on the body to heat it will get stored in the form of energy. In the same way, to raise the level of water in the tank, some work is done. So, this work done gets stored in the form of energy. So, work is done in all these cases in charging your body. That means, in case 1, case 2 and case 3, some work has been done to raise them to those levels. So, this work done gets stored in the form of electric potential energy. So, what is electric potential? The electric potential energy per unit charge is called electric potential. Now, electric potential can be calculated using the formula electric potential energy divided by charge. Now, let us analyze this example once again. What we have noticed in all these three cases is a body cannot move if kept on a level ground by itself if there is no difference in height. Suppose I have a level ground. Okay. Now, here I kept a ball. Will the ball roll towards me? This will not happen because there is no difference in the level. So, what can we conclude? A body cannot move on a level ground by itself as there is no height difference. If there is no height difference, the ball does not move. Similarly, a liquid does not flow without a level difference. Now, you can see in this case, there is no flow of liquid from A to B. Why there is no? Because of the pressure difference. As there is no pressure difference between A and B, the liquid does not flow. Whereas here, the liquid flows from A to B. In the same way, heat does not flow without level difference. Now here, the hot body is at higher temperature, the cold body is at lower temperature. If the temperatures of both the bodies are same, will there be any transfer of heat from A to B? There is no transfer of heat. So, similarly, in electrical case, for orderly flow of charges, there must be electric pressure difference called potential difference. Okay, the potential difference in an electric case is maintained by either a cell or a battery or a generator. So let us now learn about potential difference. Now let us understand what is meant by potential energy. Now, charges do not flow in a copper wire by themselves, just like water does not flow in a horizontal pipe. Now if we consider this example, here the water in tank A is full, water in tank B is full. So because both the tanks are full, you cannot expect water from A to flow into B. But when there is water which is at a higher level, and here you have tank B which is at lower level, the water will flow from A towards B till both the levels are equal. So similarly, the charges do not flow in a copper wire by themselves, just like water does not flow in a horizontal pipe. So when will the charges flow? The charges will flow only when there is pressure difference. That means when there is a difference in potential. So the difference in potential may be produced by a cell or a battery or a generator. So to maintain pressure difference within the circuit, we need a cell or a battery or a generator. Because in a cell or a battery, a chemical which is present inside the cell or a battery will help in maintaining the potential difference. That means one point is always at higher potential, the other point is always at lower potential. And the potential difference in the battery is said to be 1.5 volts. If this pressure difference is always existing, then charges can flow. Okay. So the chemical action within the cell generates the potential difference. So to maintain the potential difference between its two ends, what is important is the chemical within the battery across the terminals of the cell, even when no current is drawn from it. So this is one important point that you need to remember. When you have a cell with you, whether the cell is connected in the battery or not, you should make sure that it always will be keeping expending its chemical. Why? Because the chemical action within the cell generates the potential difference across the terminals of the cell, even when no current is drawn from it. So in an ordinary cell, when there is no current flowing through it also, the cell keeps on spending its chemical energy. So after some time, to maintain this potential energy, the entire chemical will be used up and the cell will be dead. So you should make sure when you buy cells, they should have a nearby date, not an after date. Now when the cell is connected to an electric circuit element, the potential difference sets the charges in motion. So here, if you see here, I connected this cell with the help of switch key and wires to a bulb. Now this bulb will glow. Why is it able to glow? Because it is getting energy. From where is it getting energy? Now when the cell is connected in a circuit, the electrons which are present in the circuit or the electrons present in the metallic wire carry the energy from the bulb, from the battery to the bulb. So this energy is carried by the electrons and then the energy is supplied. Now if you see carefully, if we consider this man as the electron, the energy is carried by them and is supplied to the bulb. The charge carriers will come again, pick up the energy from the cell and expend it to the bulb. So continuously the charge carriers will take the energy, supply it to the bulb and come back, take the energy and supply it to the bulb. So till there is a difference in potential, that means till the chemical in the battery is used up, the battery keeps on spending its energy to the bulb. Now once the energy is completed, that means the chemical in the battery is completed, no more supply of charge will be there or energy will be there, the battery or cell is set to be dead. So what keeps the charges to flow continuously? It is the potential difference between the two ends, that is the positive and negative. The potential difference of a typical cell is around 1.5 volts. That means the chemical within the cell is maintaining the potential difference between the two ends so that the charges will flow continuously. So when the cell is connected to an electric circuit element, the potential difference will set the charges in motion in the conductor and produce electric current. So as we know, the continuous flow of charges with respect to time is considered as electric current. So what constitutes electric current in a circuit? It's the battery which maintains the potential difference across its ends. So in order to maintain steady current, the cell has to expend its chemical energy completely. So till when the bulb will glow here, till all the chemical within the cell will get completed, the bulb will be glowing. Once the chemical energy is utilized, the bulb will not glow. So what is important here to be noted is, If there is potential difference across the ends of a cell, it keeps on expending its energy and the bulb will be continuously glowing. If the potential difference is not maintained, that means if the chemical within the battery is not existing anymore, the cell will not work and the bulb will not glow. So let us now learn what is the actual definition of potential difference. Now this is very important. What does the definition say? What is potential difference? Electric potential difference between 2 points in an electric circuit carrying some current is defined as the work done to move a unit charge from one point to other. Let us consider this example. Now, the potential difference between 2 points A and B. If I want to know the potential difference between 2 points A and B, this is defined as the work done in moving a unit charge from one end to the other. So if some work is done in order to move the charge from one end of the circuit to the other end, that difference in the 2 points, that is the difference in potential, is defined as the work done to move a unit charge from one point to other. That means here the electrons are doing certain work to supply energy from one end of the battery to the other end. So this movement of charge, for doing this work, what are they doing the work? To transfer one unit of charge from one end to the other is known as potential difference. So electric potential difference between 2 points in an electric circuit carrying some current is defined as the work done to move a unit charge from one point to other. Electric potential difference between 2 points in an electric circuit carrying some current is defined as the work done in moving a unit charge from one end to the other. So in short, potential difference between 2 points. Here, potential difference between B and A is calculated by work done by the amount of charge moved. So potential difference is denoted by V, work done is denoted by W, and charge moved is denoted by Q. So in order to move certain amount of charge, certain work is done by the electrons. So this difference in potential can be calculated by the formula V is equal to W by Q. The SI unit of electric potential difference is volt. This volt is named after the Italian physicist Mr. Alessandro Volta, who is the main person behind this particular concept. Now let us define 1 volt. When do we say potential difference is 1 volt? Generally, when we have a battery, we have a potential difference between its ends. Say 1.5 volt battery, or a 3 volt battery, or a 9 volt battery, we say. What does this mean? How to define 1 volt? Let us see. 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to other. So if you are moving a charge of 1 coulomb from one end to the other end, then we say, then the work done is 1 joule, then we say the potential difference is said to be 1 volt. So 1 volt is equal to 1 joule divided by 1 coulomb, or 1 V is equal to 1 J by 1 C in short, or 1 volt is equal to 1 joule coulomb inverse. So this is a very important definition. When we say the electric potential difference is 1 volt, when 1 joule of work is done in moving 1 coulomb of charge from one end to the other end. So 1 volt can be defined as 1 joule of work done by 1 coulomb of charge transferred. The potential difference is measured by means of an instrument called voltmeter. So voltmeter is a device that is used in order to find out the potential difference in a circuit. Let me show you what a voltmeter looks like. The voltmeter is always connected in parallel in a circuit. Why it's connected in parallel? Because when it is connected in series, it may affect the circuit. Okay? When connected in parallel, it offers low resistance to the flow of current, so it can calculate. Now this is a typical example of a voltmeter. Now if you can see, the range of voltmeter is 0 to 5. What is the least count of this voltmeter? Okay? So to find out the least count, now you can see the voltmeter is ranged between 0 to 5 and it is divided into 1, 2, 3, 4, 5. Okay? Now let us imagine that the pointer of the voltmeter is somewhere here. at a half point between 2 and 3. So what is the range here? Least count is equal to range by number of divisions. What is the range of the voltmeter? 0 to 5. So 5 divided by each line is divided into 5 equal, 10 equal points. So we will write it as 5 by 50. So 1 by 10. So one line, this one line here indicates 0.1 volt. So that is how we calculate the value. Now how many lines are there? 0 to 1 there are 10 lines, 1 to 2 there are 10 lines, and 2 to 2.5 there are 5 lines. So what is the value? Value is equal to 0.1 into 25. So which comes out to be 2.5 volts. So this reading represents 2.5 volts on the voltmeter. So generally this voltmeter is connected in parallel across the points around which you need to find out the potential difference. So voltmeter is always connected in parallel across any particular points where you want to measure the voltage. This is called parallel connection, and then this is called a series connection. So voltmeter is always kept in parallel connection only. It is never kept in series. So next we will try to solve certain numericals based on potential difference. Now before I do these numericals, we should know the formula correctly. So I just kept it in the form of a triangle, wherein if I want the V value, I have the formula W by Q. If I want W, I have the formula V into Q. If I want Q, I have the formula W by Q. So from this itself, we have three different formulas. We can calculate the potential difference, we can calculate the work done, and we can calculate the charge movement by using these three formulas. So here is the question. You are asked to calculate the amount of work done to carry 4 coulombs of charge from a point of 100 volts to a point of 120 volts. Now, here if we write what is given, we are given Q is equal to how much? 4 coulombs. We are given potential difference V is equal to 120 volts minus 100 volts. How much is the potential difference? 20 volts. Now, what is we need to calculate? We need to calculate the work done. So, what is the formula for work done? W is equal to V into Q. So, what is V value here? 20 volts. So, W is equal to 20 volts into what is the charge? 4 coulombs. So, you will get it as 80 joules as the work done is measured in joules. So, here we use the formula W is equal to V. In the same way, here he is asking how much work is done in moving a charge of 2 coulombs across a potential difference of 12 volts. So here also charge is 2 coulombs, voltage is 12 volts, work done is being present. So W is equal to VQ. So 12 into 2, which is equal to 24 joules. Let us go to the next one. So here you are asked to name a device that helps maintain a potential difference. Now there are two things to be remembered here. He is asking you to name a device that helps in maintaining potential difference, not measuring. So to maintain the potential difference across the circuit, we can have three things. We can use a cell, we can use a battery, or we can use a generator. So these are the things used for maintaining. But for measuring, what do you need? You want to measure the potential difference, you need voltmeter. So this is very important to be considered. To maintain the potential difference across the circuit, you need a cell or a battery or a generator. But to measure the potential difference, you need the voltmeter. So this is to be considered very clearly. Now how much energy is given to each coulomb of charge passing through a 6 volt battery? Here, energy is given to each coulomb of charge. So we can consider energy is equal to work done. So we are asked to find out the work done on each coulomb of charge. So charge is given as 1 coulomb, potential difference is given as 6 volts. So W is equal to VQ, which is 6 into 1, 6 joules. So in this way, we can solve numericals based on potential difference.